Oh, I'm back. I'm back so fast that it's crazy. It's nuts. Hey everyone, I'm Ryan. Welcome to day 4 of Advent of Code. If you watched the last video, day 3, I literally just finished problem 3. It's a weekend, so I'm kind of doing these back to back. So I've got my Psyduck shirt on. It's pretty sick. Oh, you can see this. I made this shirt. It's a good joke because he's a Pokemon. He says Psy. That's the Greek letters. Don't worry about it. Anyway, the point is, we're going to be diving in to some more Advent of Code problems using Elm, a language that I use at work. So I'm a web dev. I do these things. Let's get into it. Let's see what day 4 is about. All the solutions are going to be in the description of the video below, and I'm just going to be talking you through like my thought process and like how I do functional programming or whatever the heck this is. So yeah, let's see what our elves are doing in problem 4. Okay, camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of their section assignments for each pair. Your puzzle input. For example, consider the following list of section assignment pairs. Okay, so this is the example input. So it's saying for this input, within the first pair of elves, the first elf was assigned sections 2 to 4, 2, 3, and 4, while the second elf was assigned sections 6 through 8, 6, 7, and 8. The elves in the second pair were each assigned 2 sections. Yeah, so 2, 3, and 4, and 5, okay. And the elves in the third pair were each assigned 3 sections. One got 5, 6, 7, while the other also got 7, plus 8 and 9. This example list uses single-digit section IDs to make it easier to draw your actual list. Might contain larger numbers. Visually, these pairs of section assignments look like this. Okay, cool. So this is like the work that the first elf is doing, the second elf, the first elf, the second elf. This, it looks like there's an overlap on 7 here. There's a lot of overlap here. Overlap on 6. Got it. Okay. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7, and 6 to 6 is fully contained by 4 to 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so these seem like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Okay, so it looks like this is happening, and then this one's happening. So I think this is going to be an easy part 1, and I think it's going to be a weird part 2. That's my my vibe check on it. Yeah, let's check it out. So we'll start with this puzzle input. So all of my videos, we kind of just print some stuff on the screen. So I have a blank canvas here that's just printing some stuff to HTML on the right, and then I have a little spot where I can put my puzzle input. And then we're going to work through step by step, turning this into like numbers that we can work with and like parse out all this crazy stuff. So I'm going to start by doing a lot of these videos start with this, where I just do string.lines to split up this one string separated by new line characters into a list of strings, one per line that we see. So for this first line, I think what we want to do is kind of convert this raw like string input into kind of a description of what's going on. So like this means that like elf1, their min is 2, elf2, or sorry, elf1's max is 4, that kind of thing. So let's do that. Let's use a filter map. So we're going to discard any invalid lines. For example, if someone typed banana, that would be a line that we wouldn't be able to do anything with. So this filter map is going to return. It's going to filter out all the bad lines, and it's going to do that by using Elm's built-in maybe type. So I'm going to say to elf work info. So we're going to make this function together. So to elf work info is going to take one of these strings, right? So the type that's coming in is going to be a string, and maybe it'll be able to return some elf work info. What is an elf work info? elf work info is going to be something that we just made up, where we're going to store elf1 is going to have a min int and a max int, and then elf2 is going to have a min int and a max int. And this is going to kind of represent like the range of numbers. So if all of our parsing goes well, if this function returns successfully, we're going to get one of these back. And that's hopefully we're going to have a bunch of things that look more like this in our answer. Cool. So to elf work info string. So how do we start to kind of work on this? So I think what we want to do is we want to say case string.split. We're going to just be doing a bunch of like kind of string functions on this. So this is like going to be the line that comes in. I'm just going to call this line so it's a little easier to talk about. We're going to be dealing with a lot of strings during this parsing step. And then I think what we want to have is elf1's string and then elf2's string. So we can destructure that. Actually, shout out to someone left a comment on day 2's video saying that they were using Elm's like list pattern matching. That's what this is here, and it worked really well for them. So I'm gonna give this a try and see how it goes. So for now, I'm just gonna say nothing here. And then this is the only branch we care about. For every other branch, it should fail. If there's one item, you know, if there's no, basically if there's no comma in the list, or if there's like 300 things separated by commas, we're not going to worry about it. We're just going to fail to decode that line. And that's what this nothing on line 27 is about. What we're going to do here is we are going to continue to split each of these on dashes. And if we get both of those working, we're going to combine them together into a min-max. So what I'm going to do is I'm going to make a nickname for this, kind of looking ahead a little bit, the next code that I need to write. And the next code I need to write is going to be how do I parse like just this part of the code. So I think I'm going to have a really similar function called toMinMax, which is going to take a string, and it's going to give me maybe a minimum maximum like set of numbers. So what I want to do here is I want to use maybe map2. What this is going to let me do is it's going to let me take the elf1's min-max and elf2's min-max. And assuming that I got those correctly, I'm going to put them in the Elm work info. So this is like a little cool trick you can use. Min-max. We're going to give elf1 string here. And we're going to use this type alias as a constructor to create a value. So min-max is also here. Sorry, I'm kind of jumping all over the place. Min-max is actually you can use it as a function. If you give it an int and an int, it gives you back a min-max. So that's what elf work info is doing. If we give it a min-max and a min-max, it's going to give us back this record. So it's this is basically a shorthand for me saying like, hey, whatever I get, I want you to like assign the first thing to elf1 and the second thing to elf2. So this inline function is the exact same thing as this. And that's just built into Elm type aliases. When you use records, it's kind of magic. It's one of the few things I think in Elm that is kind of like magical to me. Like, oh, that's a cool trick, but I didn't see that coming. Anyway, we're gonna have a very, very similar structure to our min-max, except we're not gonna split on commas anymore. Now we're gonna be splitting on this dash, and then this is gonna be the min string and the max string. So in our example, this would be the string value 2, string value 4. And the reason I emphasize string value is we need to make sure that these things are actually ints. So we're going to call string.toInt on the min string, and it's going to attempt to turn 2, the text form, into the number 2. And so, as you can imagine, you know, they could type anything as the input. So if like someone gave us input like A, that's going to fail. We can't turn A into a number. I mean, we could, but it would be weird. It would be like you'd just be guessing at what they wanted. So what we're going to be doing is using the exact same strategy here, but we're going to be trying to turn the 2 into an integer, trying to turn this 4 into an integer, and then if both of those work, we're going to be able to use min-max, just like we used elf work info as kind of like an inline function. And that's going to give us back a min-max value, and this maybe map too is going to make sure it's a maybe. So I'm going to hit compile, and hopefully this just works. Looks like I screwed something up here. Oh, that's right. So this is going to be just string. Okay, I did a lot of talking there. It was pretty crazy. But what we did is we just got this raw line of text into a data structure that we can work with. So a lot of when you're doing development with Elm, a lot of it is just making sure that you're taking kind of the crazy outside world input and turning it into like something you can trust. So integers, I can do math with them. I can start to do logic with it. I don't want to be dealing with crazy like letters and characters for my entire program. I really want to handle that in the outside and then kind of move on. So just to give a little bit of clarity into what's going on here, our puzzle input was a string. We used string lines here to turn into a list of strings. And then we use list filter map here to turn this into a list of elf work info, which is just this big record. So if we look at the first example, the min is 2, the max is 4. If we look at this code, the min is 2 and the max is 4. And then for elf2, the min is 6 and the max is 8. So we now have numbers we can work with. And this is great because it's getting us really close to this part where we have to filter down for each elf work info. Are there any that have complete overlaps, right? So filter map. Have complete. We're going to use just a list.filter here. Have complete overlaps. And so this is going to give us, it's not going to, a filter doesn't change the shape of the data that comes back, but it allows us to kind of filter on a condition. So if you were looping through numbers, you might use a filter to say, hey, let's filter by is odd or is even. So have complete overlap isn't working on numbers, it's working on this entire data structure. So I'm going to make this function. It's going to take in one of these, and it's just going to tell me true or false, yes or no. For this specific set of work, when I look at elf1 and elf2's work, is there a problem? Does elf1 completely have a subset of elf2's number? So in the first case, 2 to 4 and 6 to 8 don't have complete overlap. Here there is some overlap, but it's not like everything. And then finally with this, 3 to 7 is completely within 2 to 8. So what we're going to do is we're going to kind of we're going to test for this in our function. So we're going to say, hey, is elf1's min greater than elf2's min? And so like 3 is greater than 2. Like, and is elf1's max less than or equal to elf2's max, for example. So that's what we're going to do. So I guess we'll just type it all out. So elf1.min greater than or equal to elf2's min. And so it's important that both of these conditions are true. Elf1's max is less than or equal to elf2's max. So that's condition 1. That's a situation with complete overlap, or it's still overlap if elf2's work is a complete subset of elf1's work. So even if we switch the elves here, it's the same logic here, but in 2 places. So I'm gonna hit compile to see if this filters down our list to just the ones we care about. And it looks like it does, and we can use list.length to get our answer. So list.length will take our list and give us the integers, an integer representing how many items are in the list. So we're left with 2. And that's the answer to this problem. But I kind of duplicated a bunch of code here. So before I run this, what I want to do is just make a nice little helper function to try to make it clear to someone reading the code that, yeah, all these characters that I typed, these are actually 100% the same, except for I switched to elf1 and elf2. So if I make a is subset of function that takes in a min-max and a min-max and returns a Boolean, all of a sudden we're going to be able to move like all this stuff into one spot. So I guess elf A and elf B is what I'm going to use here, not so we don't get confused with elf1 and elf2 up here. So what I want to do is I'm going to take the logic, replace the 1s with A's, replace the 2s with B's. And then what I want to do is, instead of completely duplicating all this code, it's really hard to scan for differences, especially when it's like one character differences. So I think is subset of elf1, elf2, or is subset of elf2, elf1 is an easier way for someone to read and see that the logic is supposed to be the same. And this also kind of protects me against typos, because I might have made one. So I compile and I still get 2, and I think we still are looking at the same. When we comment out this code, we're still looking at the same things that were comped. So that's good. I'm gonna keep these here, just so that folks reading the solution can kind of see like the values that we have at each step. And then I'm gonna save this puzzle, and I'm gonna copy the link and put it over here so I remember to put it in the video. I've got like a little notepad over here. And then what we're gonna do is, now that this is working for the example, we're gonna try it on our own puzzle input. So if you go to adventofcode.com and you sign in with GitHub or Google or whatever you want, you're gonna get a different puzzle input than me. So your answer might be different than mine, but hopefully the code will work the same for you. So for my puzzle input, the answer is 515, hopefully. Let's see if we got it right. Awesome, okay, we got 1 gold star. So things are looking good. So I'm gonna undo this get back to 2. And then, great, let's continue to part 2 and figure out what kind of twist they added to this problem to make it a little bit trickier, a little bit different. So yeah, so part 2. It seems like there is still quite a bit of duplicate work planned. Instead, they also like to know the number of pairs that overlap at all. Oh, easy. In the example above, the first 2 pairs, 2, 4, 6, 8, and 2, 3, 4, 5, don't overlap, while the remaining 4 pairs do overlap. So this example, the number of overlapping assignment pairs is 4. And how many assignment pairs do the ranges overlap? So we already did all the hard work of dealing with like, let me just change this to part 2 before I forget. Of dealing with like parsing the input and turning it into this nice data structure. And now that we have this nice data structure, we can say, let's just use a different function here. So maybe we have something called have partial overlap instead of has, complete overlap. Maybe has would have been a better name than have, but here we are. So all we need to do is we just need to change the definition of this function, and all of our code's gonna work the same. So just to kind of prove this to you, if I said true, all of these conditions are gonna return true, and we're gonna get a 6 for our answer. If I said false, all of these items are gonna get filtered from the list, and so our answer would be 0. So it's just a matter of making this logic match what we want it to match. Which is there any type of intersection? So, is 4, in between this range, or is 2 in between this range, or something like that. We'll have to figure out. I think this is like square intersection stuff. If you ever do like 2D games to try to figure out if 2 squares hit, I feel like it's like the same vibe, where it's kind of, there's like a lot more equations than you'd think. And then there's probably like an elegant way to do it that I always forget. So when I look at these numbers, what I want to do is I want to just check to see if the bounds. So for example, if elf1's min, let's just start by typing out what I'm describing. I want to know if elf1's min is greater than elf2's min. Sorry, greater than or equal to, because we care about when they're the same. If it's greater than the min and it's also less than or equal to the max, then I know that the min is within range of the other thing. So this is like one scenario where they might be the same. Another scenario is it's the same exact thing, but with the max number. So is 4 in between 6 and 8? In this case, it is, and that's why we have a problem, because 4 is not in between 6 and 8. I'm sorry, it is. That's not how math works. 4 is not in between 6 or 8, so we're okay. And then I think we have a similar situation here where I need to check if 6 is in between 2 and 4. So this kind of reminds me of like this little let expression that we made. So instead of doing this, what I can do is I can do this. Oops. And if we want, we could even break this into a smaller function. So so elf1 has partial overlap. It's going to be really confusing because these two names are so similar. I should probably think of a better name, but I'm not that clever. All right, so we're going to replace all the elf1s with elf-a's so that this becomes a little more flexible. But really, all we're going to do is the exact same pattern. So we're going to say elf1, elf2, or I'm going to say 2 elf1. And hopefully this returns 4. Good, because I did not want to debug missing an equals sign or something. And then if we really wanted to, we could move these in a function. I'm trying to think of what's a good name for this. Like is number within range, I guess. Is within range. So I would say elf a dot min elf b dot max. So we could just do this. So is within range could work. You give me an integer and you give me a min-max. Min-max is probably better just to call this type range instead of min-max. Now that I'm looking at it for like the 5th time, I'm like, wait a minute, there's a word for this. So this is like some value, and then this is like a min and a max. And then we could just say, hey, is this value greater than the min? And the value is less than the max. Because if so, then it's within the range. So what's cool about that is then we can just say, is this within range? So that also gives us 4, which is great. This is just a way to kind of clean up the code a little bit, hopefully make it a little easier for folks to read and understand. And then in the spirit of making things easy, let's just call this range. So instead of calling this min-max all over, we can even hit compile and let Elm tell us where we need to do the renames. So the Elm compiler is really good at refactoring things like this, especially. So now that I do that, there's one more spot over here. And there we go. So we just did a rename and it didn't cost us anything. So don't be afraid to make your variables easier to understand. Especially if you're doing things like this to people where you make the name like a little bit different. Anyway, I think this is right. I think this is good. I'm gonna just put these back where they were so that you can see that we're really just doing the same exact transformation with each step of this pipeline. But yeah, that's pretty much it. I'm gonna hope that this works for our puzzle input, but I feel pretty good about it. I think day 4 is gonna go smooth. So I'm gonna save that. I'm gonna compile that to make sure that still works. Copy my notes over here. And I've got the link now. All right, let's try it with our puzzle input. Moment of truth. Do this. Number I get is 883. Awesome. All right, look at us go. We are 4 days in. We have 8 gold stars. Thanks for hanging out. I'm gonna record another one of these for day 5. because I'm not burnt out yet. So let's keep going. Yeah, so in the description of the video, I'm gonna have all the solutions, links to Advent of Code, links to Elm if you want to learn more, including like some of the functions that we used in today's video that are available in the official core library. So all these things like list, filter, map, string lines, everything is fully documented for you in Elm. So you can always, if you're curious about any of the functions we used, you can just use this thing. I'll have a link in the description, and you can kind of see examples of how it works and what it takes in and what it spits out. And hopefully that'll make you feel smart. Cool. Well, thanks for hanging out. I'll catch you all later, and have a lovely December. Goodbye.